Hello everybody! So what we're going to do in these next couple days and these next couple videos is go back through a lot of the topics that we learned this semester to sort of help refresh your memory before our final exams. So the first chapter we're going to spend a little bit of time reviewing is the chapter 6, Information. So in chapter 6 we were talking about solving systems of equations. In this chapter, we learned 3 different ways that we could solve a system of equations. The first way we learned we could solve is by graphing. So what I would do here is I would graph each of these lines and look for where they intersect. I'm going to graph the first line in red, and I'm going to graph the second line in green. So for the first line, I would begin at the positive 6, and then I would go, because the slope is negative 1, down 1 over 1, down 1 over 1, down 1 over 1. And I would draw my line. For the second line here, I would start by putting a dot on the negative 2, and then I would go up 1 over 1, up 1 over 1, up 1 over 1, and draw my line. Now the solution to a system of equations is a point where the 2 equations intersect. So my solution here would be the point 4, 2, because that is the intersection point. Now another way we learned that we could solve a system of equations was using something called substitution. So what we said was that if y is equal to 6x minus 1, we can replace the y in the other equation with 6x minus 1. So what that's going to mean is that I'm going to copy the first equation. I'm going to have negative 3x plus 2. And instead of the y, I'm going to write parentheses 6x minus 1, and then I'm going to copy the equals 7. So I'm leaving everything the same, negative 3x plus 2 and equals 7. The only thing I'm changing is the y becomes a 6x minus 1. Now I'm going to solve this equation. So I'm going to have to distribute my 2. So I'm distributing the 2. This is called substituting, distributing. I'm going to combine like terms. So I'm going to have 9x minus 2 equals 7. And then I'm going to add the 2 on both sides, and I get 9x equals 9. And then I'm going to divide by 9 on both sides, and I get x equals 1. Once I know my x, my next step is going to be to figure out my y. So I'm going to take this x, and I'm going to plug it back into the original equation. And it doesn't matter what equation I use, it just matters that I plug it into one of the originals. I'm going to plug it into the second equation because the y is already by itself. So now I'm going to do y equals 6 times, and instead of x, I'm going to substitute in the 1 that I just calculated, and I'm going to get y equals 5. Which means my final answer here, the point of intersection, would be 1, 5. Finally, the third solution method that we learned was called elimination. We said elimination works best when everything is lined up. So the x's are on top of each other, the y's are on top of each other, the equals are on top of each other, and the numbers are on top of each other. The goal for elimination is to make one of the variables cancel. So in order to do that, I need them to have the same number but opposite signs. In this problem, I'm going to try to make the x's have the same number but the opposite signs. So I'm going to multiply the first equation by 3 and the second equation by 4. And I'm going to take this and I'm going to make it a -3 so that that will become a negative coefficient for the x. Now when I distribute that to all of the coefficients, my new coefficients are -12x minus 15y equals -300. And my second equation is going to be 12x minus 8y equals 24. So all of the numbers change, but the x's and y's stay the same. Now when I look at my new equation, I'm going to notice that the 12x and the 12x are going to cancel. So if I add, I get -15 plus -8 is -23y. -300 plus 24 is -276. And then I'm going to divide by -23. So what I get is y equals, I believe it's 12, but I'm going to double check that on my calculator. Yes. Once I know my y, I'm going to take that and plug it back into one of the original equations. I usually use the first one and solve for x. So I'm going to have 4x plus 5 times, instead of y, I'm going to have 12 equals 100. Now I'm going to solve. So 5 times 12 is 60. I'm going to subtract 60 on both sides. So I have 4x equals 40. And then I'm going to divide by 4 on both sides. So I have x equals 10. What that means is that my final answer should be 10, 12, because that would be the intersection point. All right, next, sometimes when we solved these equations, we got some weird answers. Sometimes we had equations where there was no solution. Sometimes we had equations where there were infinitely many solutions, and sometimes we had equations where there was one solution. So let's review what this means. When there's no solution and you're solving it by using substitution or elimination, you're going to get something that is never true. So you're going to get something like this: 0 equals 7. Now 0 does not equal 7, and there are no x's left in the problem. So there's no way to solve this to make it true, which means there would be no solution. If you were graphing, you would get two lines that do not intersect. So you would get parallel lines because they would never intersect. If you have infinitely many solutions, you're going to get something that is always true. For example, you would get 2 equals 2. Or 0 equals 0. Again, there is no x. There's no way to solve these. There's no rearranging. It's just a statement that is always true. So because of that, we would say that there are infinitely many solutions. Now, when you're graphing, you're going to get two lines that are right on top of each other. They intersect everywhere. Finally, we had one solution. So you're going to get a single intersection point, a single answer. So at the end of the problem, you would have x equals 7 or y equals 10. In this case, we're not saying something that's always true. We're saying it's true as long as x equals 7. So it's true once. When you're graphing, you're going to get two lines that intersect in one spot. In this chapter, we also did word problems. So we're going to go ahead, we're going to skip this one, and we're going to do number 5. We're going to do word problems. So write the system of equations you would use to solve the following problems, but do not actually solve. Actually, let's go back and do this one. I was just kidding. We're not going to skip it. So for problem 4, if you wanted to solve this, the best way to do that would probably be to use elimination because everything is nice and lined up. In order to make your coefficients the same but with opposite signs, you would just have to multiply the bottom equation by -3 because that's going to turn the coefficient of the x into a -6. So I'm going to copy down the first equation. I'm not going to change it. 6x minus 3y equals 15. And the second equation, all of the coefficients are going to change. So -6x plus 3y equals 21. Now when I solve this one, what I notice is that the x's cancel, the y's also cancel. So I end up with 0 equals 36. Now this is something that is never true. So for this problem, we would write no solution. All right, now let's talk about word problems. So we're just going to set up the equations. We're not going to actually practice solving these. We've already reviewed solving systems of equations. We're just going to practice setting these up. So it says in the first example, the difference of two numbers is 2. Their sum is 22. Find the numbers. Now the word difference means subtraction. So if I take my mystery numbers, x and y, and I subtract them, it tells me that the answer is 2. It also tells me that the sum, which means addition, so if I take those same two numbers, x and y, and I add them together, I get 22. Now if I did want to solve this, I would probably solve it using elimination. But we're not going to spend our time right now solving that because we did just practice solving using elimination twice. For problem 6, it says Heather's school is selling tickets to a choral performance. On the first day of ticket sales, the school sold 10 adult tickets and 2 student tickets for a total of $98. The school took in $154 on the second day by selling 2 adult tickets and 10 student tickets. What is the price of 1 adult and 1 student ticket? So if we're selling on the first day, it said we sold 10 adult tickets, so 10A, plus 2 student tickets, so 2S, for a total of $98. I'm just taking this sentence and turning it into an equation. Then it says that the next day we sold 2 adult tickets and 10 student tickets, and it says we made a total of $154. Again, I would probably solve this one using elimination, but we're not going to go through that right now for the sake of time. The final thing that we learned in this chapter was how to graph linear inequalities. So we said that when there's a dotted line, it's because we either had a greater than or a less than. There was no equal to. When we had a solid line, it was greater than or equal to or less than or equal to. We shaded above when we had a greater than or equal to. So above was always greater thans. And we shaded below when we had a less than or equal to. So if I gave you this graph and I said write the inequalities that you would have had, we're going to do this in 2 different steps. We're going to have the red line, which was a solid line, and we're going to have the blue line, which is a dotted line. So I'm going to work on the red line first. For the red line, the slope of that line and the y-intercept are things that I need if I want to write the inequality. So the slope would go from here to here. So I would rise 3, run 1, which just simplifies to 3. Now the y-intercept is also 3 because it crosses the y-axis in the 3. So I would write y and then mx plus b, so 3x plus 3, and I'm going to leave a space. Now if I look at this line, the shaded part is above the line. So I would use the inequality greater than because I'm shading above. And since it's solid, I would use equal to. For the blue line, again, I'm going to need to know the slope and the y-intercept to write this equation. The y-intercept is probably the easier part. It's just -2. For the slope, I would go from here to here. So I would rise 1, run 2. So my equation would look like, my inequality would look like this. Y, and then I'm going to leave a space, equals 1/2 x minus 2, mx plus b, just to remind you where that's coming from. Now the inequality that I would use here, since I'm shading above, again, I would use a greater than. But since it's a dotted line, I would not use an equal to. So my answer would just be this. All right, thank you guys so much for watching. I hope this was a helpful refresher of what we learned in Chapter 6, and I will see you guys for some practice tomorrow.